Alright folks, so welcome to another episode of Math with Dr. Math. Alright, so what we're going to look at here are rational exponents. So go ahead and copy this down. We are looking at section, so let's write this down. We are looking at section 7.2. So rational exponents. Alright, so copy down this first definition. It says define a raised to the 1 over nth power. So this is our base, and this is your exponent. So make sure you write this nice and small so that you could indicate to yourself that this is our exponent. Alright, so we're going to make this definition here. So if the exponent, right, is a whole number, so copy down a here. If the exponent is a whole number, it means, alright, so we're going to take you down memory lane here. So looking at this, 3 squared, alright, so we know what 3 squared is. So 3 squared is just 3 times 3. Alright, so that's just 9. Alright, nothing new there. Alright, and then we have 2 raised to the power of 0. So anything raised to the power of 0 is what? Good. So if you heard them in the back, they said anything raised to the power of 0 is 1. Excellent. And then here we have 4 to the power of 3. So we know that's 4 times 4 times 4. Alright, so we have 4 times 4, 16. 16 times 4. We left with 64. Alright, so this is where we already know, right? So these are regular exponents that happen to be whole numbers. Hopefully we recall. Alright, let me get my little cursor here. So hopefully we recall that if the exponent is negative, alright, it means the following. So what's going to happen to your base here? In this particular case, our base is 3. So what's going to happen to this base if our exponent is negative 1? Excellent. So that base is going to shoot to the bottom. And our negative 1 is now going to become positive 1 when it moves to the bottom, right? Because that's our definition of exponents that we covered earlier. So again, what this does is it takes the reciprocal of whatever this base is. It's going to flip it, right, if you think about it. Because 3, we could always write it as 3 over 1. Alright, so that's telling us that 5 to the negative second power. Alright, so we're going to take 5, raise it to the negative second power. So this is going to give us 1. Oops. This is going to give us 1 over 5 squared, right? So we know that is 1 over 25. Alright, so that's what we're at right now. So that's what the negative exponent tells us. Alright, and hopefully we remember that. Okay, so we're going to use those ideas shortly here. Okay, so let's move on. Let me move this up so everybody could see. Alright, so next, let me get my highlighter here for you. Alright, copy down C. So what if the exponent is a fraction? Alright, that's what we're going to be handling today. What if the exponent is a fraction? Okay, so let's start with 9 raised to the negative, 9 raised to the 1/2 power. Alright, so pretty soon what you're going to see, you don't have to copy this part. So again, don't copy this. Let me scratch it out. But this is kind of what we're going to see. Let me scratch this out so you're not copying this. What you're going to see is that this is the same thing as the square root of 9. Alright, so whenever you have 9 to the 1/2 power, you're going to make the connection that that is the same thing as the square root of 9. Alright, and I'm going to help show you that. Alright, so again, I'm just telling you this. You don't have to copy that down. And then we don't have to copy this down, but let's read it, make sure this makes sense. So by definition, right, we talked about that definition on Monday. It says a square root of 9 is a number such that some number squared is 9. So what number would you have to square to give you 9? Alright, so we got some options here. So let's look at this. Alright. By our properties of exponents, let me get my highlighter back in this. What do I do with this 1/2 and this exponent of 2? Good. So whenever you raise a power to a power, you multiply these exponents. So these exponents get multiplied. Alright, so we end up with 9 and 1/2 times 2. Well, that's just 1. So you could see these kind of cancel each other out. Alright, so our answer here is just 9. So these undo one another. This guy and this guy, they're the inverse. They undo one another. Likewise, go ahead and copy down example 2. We don't have to write down these words. Alright, so go ahead, example 2, just copy down what I circled. Alright, so now we will consider 8 raised to the 1/3 power. So again, don't copy this, but this is what we're looking at. Alright, so we will see that this is the cube root of 8. Okay, so this is the same thing as that right there. And again, I'll give you a definition in a few minutes. But this is where we're walking towards. Alright, so to save some time on the video, we'll skip this line here. Alright, so again, just copy down what I'm kind of telling you to. Save you some time. Alright, so again, what's going to happen to these exponents? So, what's going to happen to this 1/3 and this 3? Again, they're going to cancel out. So you're left with 8 raised to the 1st power, which is just 8. So we could see when you cube something, to undo this, you have to raise that number to the 1/3 power. So these are the reciprocals of each other, right? They cancel each other out. Alright, so let's give you some notation. So in general, we are going to copy this down. So D, go ahead and copy this down. So you are going to copy in general. Alright, so write that down. In general, when you have some base A, right? A could be some number. We're going to define it right now. And when you raise A to the 1/n power, right? In general, A to the 1/n power is, right? We're going to define it. This is the nth, right? We say this is the nth root of A. Alright, that's how we're going to read that. So this is the nth root of A. And the way we're going to denote that, alright, so the way we're going to denote this, let me shrink this a little bit, give you some space. We're going to denote this by, get my pen back in here, get some pen action in here, is the nth root, so the index, right, we talked about that word, the index is n, and my radicand is A. So whenever I say the nth root of A, this is how we denote it, the nth root, and that's the letter A. So this A is our radicand, radicand, right now space here, bam. Alright, so that's how we denote this. And this is called radical notation. Alright, so this is radical notations. Alright, so let's look at some examples so we can play around with this. Alright, so let's look at some examples. Oops, I didn't mean to do that. Okay, so let me scroll up here. Alright, so these examples are going to take us to promised land. So here we go. So it says use radical notation, and what we want to do is we want to rewrite each of these. All right, and we want to simplify if possible. Okay, so whenever we have the square root, right, because that's what this is, 1/2, that's really just the square root of 100. So let's rewrite this. This is the same exact thing as the square root of 100. And remember we discussed earlier that this number on the bottom here in our denominator, this is our index. So that 2 is your index. So go ahead and write that down. That whatever's in the denominator here is your index. So what's the square root of 100? Good, it's just 10. Perfect. All right, so let's move on to number 2 here. We have negative 64 raised to the 1/3 power for number 2. All right, so what this is saying, according to what we just said, this is the third root, because again, the number in the denominator is our index. So there's our index, and this base is our radicand. So that goes in the inside. All right, so we have the cube root of negative 64. So what raised to the 3rd power will give you negative 64? Well, that's just negative 4, because negative 4 times negative 4 times negative 4 will give you negative 64. All right, this number 3 is a little tricky, all right, because now we're talking about what root? Good, we're talking about the 4th root, because that is in our denominator. All right, so we're talking about the 4th root. So we have the 4th root of 81. Notice, I didn't write that negative, this negative. Why didn't I write it? Excellent, it wasn't in parentheses. So this negative, leave it out in front, because it was not in parentheses. So this exponent right here only belongs to the 81. It does not belong to this negative sign right here. All right, so that's why the negative, you just drop it like it's hot, bam. And we know our index here is always the denominator, which is 4. All right, so what number times itself 4 times will give you 81? All right, and if I heard correctly, I heard it's 3. And then again, bring down that negative sign. So there you have it, folks. All right, so let's take a commercial break, and then we'll be back at it in a few minutes.